All right, good morning. Today is April 14th, 2020. I am Mr. Trutna. This is Math 2. And in today's lesson, we're going to go over two concepts that we're going to talk about that'll coincide with your worksheet that you're going to be given. So the two concepts that we're going to go over is, the first one is we're going to go over the idea of expanding binomials. And the second concept that we're going to go over will be completing the square. Complete the square. Okay? So the first concept, expanding binomials, and for this week, a lot of what we're going to do is going to be review of what we've talked about in the previous weeks. Hold on, notice that I'm a little out of focus here, so let me get my machine to adjust. Okay, so the first concept, expanding binomials. What this is going to look like is that you're going to be given a binomial, and if you recall, a binomial means two terms. Okay, and the terms are always separated by a plus or a minus, and they're going to look like this. So you're going to have a parentheses. And inside the parentheses, you're going to have a binomial, like let's say x plus 2. And then you're going to have that parentheses to the second power. And we're going to go over the concept of how to expand these binomials correctly. Okay, so notice that the x plus 2, x is a term, 2 is a term. They're separated by a addition symbol. They cannot be added together, so this is what we call a binomial. Okay, so the key to this is that you have to remember that this power of 2 is telling you right here that there are two sets of x plus 2's. So immediately in your mind, and it's probably a good idea to write this out, you want to rewrite this problem as, instead of just one set of x plus 2's, you want to write it as two sets of x plus 2's. Remember when we talked about an exponent? An exponent tells you to take whatever is below it, called the base, and in this case the base would be x plus 2, and multiply it by itself that many times. So this exponent of 2 is saying you have two sets of x plus 2's, and you need to multiply them by itself 2 times. Okay? So then now the question becomes, how do we multiply x plus 2, a binomial, times x plus 2, a binomial? And the strategy that we learned on how to multiply these was we made what we referred to as the rectangle, the magic rectangle. Okay? Whatever's in the first term, x plus 2, you write along the top. You put the x here, and then you don't put the plus 2, kind of shift it over. Draw a vertical line to divide this rectangle into two smaller rectangles. And then whatever's in the second term, x plus 2, put it along the left side, and write the plus 2 like this, because you need to remember that that's going to be a positive 2. And right in the gap here, draw a line. Okay, so what we're going to do now is if you recall, we're going to use multiplication. And we're using multiplication, and we're going to fill in each one of the 4 smaller rectangles by always multiplying the left side times the top. So you can see in this top left-hand rectangle, we're going to take the left side of the rectangle, x. We're going to multiply it by the length of the top of it, x. And whatever that result is, we're going to write it inside here in a larger format. So x times x is x squared. Okay, and then we're going to go over here to the top right rectangle. We're going to take its left side, which is x. We're going to multiply it by how long the top of it is, which is positive 2. And x times 2 is 2x, and we're going to write the result right there. Okay, then we're going to go down and we're just going to continue this process for the bottom left and the bottom right rectangle. So the bottom left rectangle, the left side is 2, positive 2, times the length of the top of it is x, and 2 times x is 2x. And then we're going to do the same thing for the bottom right rectangle. We're going to take the left side of it, which is positive 2. We're going to multiply it by the length of the top, which is positive 2, and 2 times 2 is 4. So your answer to x plus 2, when we expand it to the second power, is going to be the combination of all 4 of these smaller rectangles added together. Okay? So my answer is going to be x to the second power added to 2x added to 2x added to 4. And that would be your final answer right there, if and only if you cannot combine like terms at all together. And you could see that you could actually simplify this expression, because we can combine the positive 2x with the positive 2x to make positive 4x. So in reality, this is equal to x to the second power. There's nothing we can combine x to the second power with, plus 2x plus 2x is 4x plus 4. Okay? So that right there would be your solution to expanding the binomial x plus 2 to the second power. So what we have just said is that if you start with the binomial x plus 2 in parentheses to the second power, when you expand it out and you multiply it out, you get x squared plus 4x plus 4. So that's what we mean by expanding the binomial. Okay? Let's do another example here, number 2, just so we get the hang of how to do this. Okay, so number 2, let's say we have a binomial, and let's look at one where there's a subtraction symbol. So let's say we have x minus 8 in parentheses to the second power. Okay, so remember what that means once again is that this second power right here is saying that we have 2 sets of x minus 8s, and we're going to multiply those 2 sets together. So this problem is saying you have 2 sets of x minus 8s, and you need to multiply those 2 sets together. Okay? So we need to multiply the binomial x minus 8 times the binomial x minus 8. And once again, the strategy that we learned to do that is, and it's not the only strategy, but we learned how to multiply these out by using what we called the rectangle. And essentially what we're doing is we're using an area model to find this. Okay, so take the terms in the first parentheses, x and minus 8, and write them along the top, x, and then shift over the minus 8 here. Draw a line, vertical line. Take the second term, x minus 8, write it along the left side, put the x here. Now when you write the minus 8, write it like this, so you know you're going to treat that as a negative 8. And then once again, we're going to find the area of each one of these 4 smaller rectangles by always multiplying the left side, x, times the top, x. Or some people call it the base and the height, or the length and the width. Either way, we get x squared. Okay, then we're going to go over to this top right rectangle. We're going to take the left side of it, which is x. We're going to multiply it by the top, which is negative 8, and x times negative 8 is negative 8x. Go down to the bottom left rectangle. We're going to take the left side, which is negative 8. We're going to multiply that by the length of the top, which is x. Negative 8 times x is negative 8x. And we're going to do the same for this bottom right rectangle. So we're going to take the left side, which is negative 8. And we're going to multiply it. Now remember, the key is we're multiplying, we're not adding yet. And we're going to multiply it by the top, which is also negative 8. So that gives me positive 64. So then once again, remember my result would be the combination of adding all each one of these 4 rectangles together. Okay? So that means that x minus 8 to the second power, when we write it out, is x minus 8 times x minus 8. And that's going to be equal to x squared plus negative 8x plus negative 8x plus 64. So it's a combination of all 4 of these added together. And once again, that would be your final answer if you couldn't simplify this, but you could see we have like terms with the negative 8x and the negative 8x. So when I combine these together, I'm going to get x squared. There's nothing alike with x squared, so I'm going to have an x squared. And then when I combine the negative 8x and I add it with a negative 8x, that gives me negative 16x, and I could just write it like that. And then I have a plus 64. Okay, so once again, what we're saying is that if we take the binomial x minus 8 to the second power, and if we expand it, it becomes x squared minus 16x plus 64. Okay, so that's going to be the idea of how we expand binomials there. Okay, and this would work every single time that you are expanding a binomial, even if you have fractions. Okay, so that would be the first thing that we want to go over, is expanding binomials. And then the second thing is we want to go over how to complete the square. Okay, so the second concept is complete the square okay, and then we're going to put finding the value of c. Okay, so remember when we talked about quadratics, we talked about when we talk about a quadratic, remember, is any expression or equation where the highest exponent you see is 2. And then we talked about in quadratic, there's a couple different forms, but one of the forms that we've talked about in class is there is what we call the standard form of a quadratic. Okay, so a standard form of a quadratic is any quadratic in the form of ax squared plus bx, plus bx plus c. Okay, where in this expression right here, a and b and c are just going to be numbers. So a, b, and c are going to be integers. And integers just mean that they're going to be numbers. So for instance, let me give you an example of that. A quadratic in standard form, if I said, say, 2x, or how about 12x to the second plus 3x minus 9. In this case, your a value would be 12, your b value would be 3, and your c value would be negative 9. So what we're going to do in this section is you're going to be given a quadratic like x squared plus 10x plus c, and you're going to be asked to find the value of c so that it does a process called complete the square. Okay, and then you guys have, as we've learned here, is that complete the square is actually a process that we use to solve a quadratic equation. Okay, but today we're just going to review how do you find the value of c to start the process of what we call complete the square. Okay, and the process is actually pretty simple, and here's how you're going to do it, and we'll do 3 examples of this. So what you do to find the value of c to complete the square is the first thing that you do is you take the b value, and in this case the b value is 10. Okay, go ahead and write that b value down, 10. Now remember, the b value is just 10. It's not 10x, okay? It's just the coefficient in front of the variable x. Okay, and then what you do is, whatever that b value is, you divide it by 2, which would be equal to 5. You get a result, and then you raise that result to the second power. Okay, and whatever that equals, that would be your c value for completing the square. All right, so what is 5 to the second power equal to? Well, that is equal to 25. So in this case, c would have to be equal to 25. Okay, so we would have c would be equal to 25, which means that when I complete the square, I'm going to get x to the second power plus 10x plus 25. Okay? That would be the process of what we mean by completing the square. And notice this right here is a trinomial, and it's actually a special trinomial. It's called a perfect square trinomial. And we'll talk about in the next lecture what's the importance about a perfect square trinomial. But right now we just want to focus on how do you find the value of c to start the process called complete the square. Okay, let's do another one, number 2, where we have, instead of a plus, we have a minus here. So how about if we have x to the second power minus, and it could be anything. Let's go ahead and do 22x plus c. So once again, we want to find the value of c to start the process of what we call complete the square. Okay, so how do we do that? Well, we take the b value, remember, and the b value in this case is negative 22. And then the process is, whatever the b value is, you divide it by 2. That's equal to negative 11. And then you raise that result to the second power. And whatever that equals, that's what your c value is going to be. So what is negative 11 to the second power? That is positive 121, excuse me. So that means my c value is going to be positive 121. Okay? So that means that when I write out my trinomial replacing 121 with c, I would get x to the second power minus 22x plus 121. And once again, for terminology's sake, this right here would be what is known as a perfect square trinomial. Okay? So that's how we find the c value to start the process of completing the square. Now, if you notice, in example number 1 and number 2, the b value 10, the b value 22 was an even number. And when the b value is an even number, the c value is nice and friendly what you get. But let's do one example where we have the b value is an odd number, so we know what to do. So let's say we have x squared plus 5x plus c, and I say find the value of c in order to complete the square. Okay, so how do we do this? Well, we're going to take our b value, which in this case is positive 5, and we go through the process that was described above. So we're going to take that b value, positive 5, and we're going to divide it by 2. Now this brings up an interesting point. When you divide 5 by 2, you get a decimal. Okay, so if you get a decimal when you're finding the value of c to complete the square, don't write the decimal. So if it doesn't divide in evenly, just leave it. So 5 divided by 2 would be 5 divided by 2, and then the process is you are going to then square that result. And then remember, once again, whatever that equals, that's going to become your c value. Okay, so what is 5 over 2, or 5 halves to the second power? Well, that's pretty easy. What's 5 to the second power? That's 25. Over what's 2 to the second power? That's 4. So that's telling me that my c value is going to be, and we're just going to leave the answer as a fraction, would be the fraction 25 over 4, or 25 fourths. Okay, so when you're starting the process of completing the square, if your b value is an odd number, that's going to give you a fraction, because when you divide by 2 it won't go in evenly. Leave it as a fraction and then square it. Okay, so that means when I write this out, I'm going to get x to the second power plus 5x plus, and then instead of c, I'm going to replace it with its c value, which is 25 over 4. And then remember, once again, this right here, this is a trinomial, and it is what is termed as a perfect square trinomial. Okay, so that's what your worksheet's going to be on for, your first worksheet's going to be on for this week. Good luck with it.